Welcome, curious minds, to another deep dive.
Glad to be here.
Have you ever been part of a software project that just felt, well, bogged down?
Oh, definitely.
Not by a technical glitch or, a server error, but by the sheer overwhelming complexity of what the software was actually supposed to do. You had talented engineers, state-of-the-art tech, but the core business logic, the actual domain of the user's activity, just became this tangled, confusing mess.
It's a remarkably common pitfall. As Eric Evans, whose foundational book we're exploring today, puts it, the most significant complexity of many applications is not technical.
Right.
It is in the domain itself. And when that inherent complexity isn't truly understood and handled in the design, well, even the most elegantly crafted technical infrastructure can become irrelevant.
Like building an incredibly powerful engine.
Yeah.
But for a car that can't stay on the road because the driver doesn't know where they're going.
That's a perfect analogy. Exactly.
And that's exactly where today's deep dive comes in. Domain-driven design, or DDD. It's a powerful philosophical approach aimed at tackling this very problem head-on by truly focusing on the core business logic.
Getting to the heart of it.
Our mission today is to unpack Evans' seminal 2003 book, Domain-Driven Design, Tackling Complexity in the Heart of Software. We'll extract its key insights, helping you understand how a philosophy, which Evans describes as an undercurrent in the object community, can transform software development, making your applications adaptable, maintainable, and deeply connected to their real-world purpose.
Okay, let's dive in.
So let's unpack this core idea. The real complexity, Evans argues, isn't in the lines of code, but in the actual business domain you're trying to model. Why is that distinction so crucial?
Because if you don't grapple with that domain complexity first, your brilliant technical solutions might just be, well, beside the point.
Right.
Imagine you've built the most optimized distributed database system in the world. But if your fundamental understanding of what a customer means for your business is flawed, or if order processing doesn't reflect your actual workflow,
Then you're in trouble.
then you're building on quicksand. The infrastructure is magnificent, maybe, but the software fails to serve its true purpose.
So DDD offers a way out of that quicksand. What are its foundational premises? What's the core thinking?
It really boils down to two core ideas. First, for the vast majority of software projects, the primary focus must be on the business domain and its logic.
Okay, focus on the business.
Second, when that domain is complex, its design should always be based on a carefully constructed living model, not just a static picture.
A living model. Evans really drives this point home with an anecdote John Cleese told about a film editor, right?
Yeah, it's a great one.
The editor was so obsessed with technical perfection, like making sure a stray coat sleeve didn't appear in the frame, that he ended up choosing a take that completely lost the heart of the scene.
Exactly.
What's the takeaway for us, the developers?
It's a powerful caution. We, as developers, can get so absorbed in the technical brilliance of our solutions, writing perfectly optimized algorithms, leveraging the latest frameworks, chasing architectural patterns for their own sake, that we completely lose sight of the core domain problem. The software might be technically flawless, but if it doesn't truly solve the business problem, or if it fundamentally misunderstands the user's activities, it risks becoming irrelevant.
So technical excellence isn't enough.
Technical excellence without domain relevance is wasted effort. That's the key insight.
If the domain is where the real complexity lies, how do we actually crunch that knowledge and forge a deep understanding? Because it's not just about drawing a diagram once and being done with it, is it?
Oh, not at all. Evans emphasizes that a domain model is not a particular diagram or just the knowledge in a domain expert's head.
Okay.
It's far more profound. It's a rigorously organized and selective abstraction of that knowledge.
Rigorously organized and selective.
Yes. In simpler terms, it's about taking all that messy, real-world business knowledge, carefully selecting what's truly relevant to the problem you're solving,
Filtering it.
and then organizing it into a coherent, focused understanding that we can then translate into software.
I found the story Evans tells about designing a printed circuit board, a PCB, design tool fascinating, especially since he had no electrical engineering background. How did they even begin to tackle that?
It's a great illustration of knowledge crunching in action. Instead of trying to become an EE expert overnight,
Right, impossible.
they wisely limited their initial exploration to a very specific, manageable feature: probe simulation.
Smart. Narrow the focus.
Exactly. This allowed them to engage in an intense, iterative process of brainstorming and refining, questioning and explaining with the true domain experts. Evans would build concrete prototypes. No persistence, no UI, just raw Java objects with dummy data.
Just the core logic.
And these prototypes would clarify the model for the experts, leading to immediate, invaluable feedback.
So it wasn't about getting it right the first time, but about a constant feedback loop, like a conversation.
Absolutely. And what was the outcome of this iterative process? It became a living, evolving understanding. This back and forth consolidated synonyms discarded hundreds of irrelevant facts that, while true about electrical engineering, weren't pertinent to this software.
Got rid of the noise.
And ultimately created a robust framework for both learning and precise communication. The code and the model truly co-evolved, leading to a tool that exceeded everyone's expectations.
So the key insight is that a truly useful domain model is a collaborative, iterative creation, not some static document you write once.
Precisely. It lives and breathes with the project.
And this leads directly to what Evans calls the ubiquitous language. This is where things get truly transformational for a team, isn't it? What exactly is it?
Well, the model that emerges from this rigorous knowledge crunching doesn't just sit in a document. It becomes the backbone of a language used by all team members.
Everyone uses the same words.
Yes. The real magic is that developers literally program in this language, and they can communicate with domain experts without translation.
So you're saying it breaks down the barrier between the business side and the technical side. That sounds incredibly powerful for preventing misunderstandings and, building the right thing.
Exactly. This constant refinement of a shared language forces developers to learn important principles of the business, and it pushes domain experts to distill what they know to essentials.
So everyone gets smarter about the domain.
You're not just building features, you're building a shared understanding that permeates the entire team and, crucially, the code itself.
Okay.
And Eva makes a critical point here. Recognize that a change in the ubiquitous language is a change to the model.
Wow. So the words change.
The model has to change. The profound implication is that if the words your team uses to describe the business change, your software's underlying concepts, and therefore its design, must also change to reflect that new understanding. The language isn't just a label, it is the model.
I love the example from the book, that dialogue about a routing service, instead of vague discussions. Once they explicitly defined object names like itinerary and route specification, the conversation became precise and concrete. The user could say, the itinerary is the main thing they'll need, referring to a tangible object, not just some vague idea.
Right, it gives you handles to grab onto.
It revealed much deeper business intent.
And that precision aids both communication and design. It also highlights that diagrams, while useful for communication, are just a means of communication and explanation, and are best if minimal.
They're not the model itself.
No. The true living model is found in the ubiquitous language, which then finds its most detailed expression in the code. As Evans states, the code can serve as a repository of the details of the design.
So the code is the detailed design.
In a way, yes. The deeper insight here is that a shared, precise language is the ultimate tool for aligning software with business reality.
So once you've done all that hard work to build a clear, evolving domain model and a ubiquitous language, how do you make sure that model truly drives your software's implementation?
Yeah.
Because it would be a shame to lose all that hard-won insight, right?
Absolutely. This is the core of model-driven design. The model isn't just an artifact for early analysis, it's the very foundation of the design.
Not just a blueprint you throw away.
Exactly. Evans contrasts this with what he calls analysis models that are often developed separately without considering how they'll actually be implemented. These models frequently get abandoned once coding begins,
Yeah, I've seen that happen.
forcing developers to effectively resolve the same problems and losing critical insights along the way.
Like the astrolabe.
Yeah.
Right. That wasn't just a pretty drawing. It was a physical implementation of a model of star positions. It made the model real and usable.
Precisely. Or think about the classic Internet Explorer favorites example. The user's mental model is simple, a list of website names. The implementation, however, treats a favorite as a file on the file system. If a web page title has characters illegal in file names, i.e. would just quietly change data, stripping them out.
Oh, right. Leading to weird favorite names.
That mismatch between the user's conceptual model and the software's implementation causes subtle confusion, and in more complex real-world applications can lead to serious bugs.
So the key insight is that your code is your model. If they diverge, your software will inevitably disappoint. They have to stay in sync.
They absolutely have to.
So the classic architect in the ivory tower problem, where modelers are completely separated from the implementation process, becomes a real danger here, doesn't it?
It really does. They lose touch with practical constraints, leading to models that are impractical, or, as Evans puts it, where developers could no longer risk being saddled with the dictates of the architect in the ivory tower.
Okay, so how do you prevent that? How do you keep the implementation aligned?
Absolutely. To keep the implementation sharp, focused, and truly aligned with the model, Evans strongly advocates for isolating the domain through a layered architecture.
Layering, okay.
This separation is crucial for maintaining focus and ensuring the longevity and maintainability of your system.
Can you break down those layers for us and explain why that separation is so vital?
Certainly. At the top, you have the user interface, UI layer, which handles displaying information and interpreting user commands. Pretty standard.
Okay.
Below that, the application layer orchestrates the workflows, defining the jobs the software needs to do, and coordinating domain objects to perform those jobs. It's kept intentionally thin, though. It contains no business rules itself.
So it's like a traffic cop.
Kind of, yeah.
Huh.
Then comes the crucial domain layer, or model layer. This is the heart of business software.
Where the real logic lives.
It's solely responsible for representing business concepts, situations, and rules, with its state directly reflecting the business situation. Finally, the infrastructure layer provides generic technical capabilities like persistence, messaging, or testing support. The plumbing.
And the really important thing is that the domain layer is where those fundamental business rules live, right? Like Evans' credit debit rule, which states every credit has a matching debit.
Exactly. That's not just an application workflow detail, it's a core business invariant.
Yeah.
A fundamental truth about the business.
Makes sense. And speaking of architectural choices, Evans actually identifies something called the smart UI as an anti-pattern in the context of domain-driven design.
He does, surprisingly perhaps.
It seems intuitive for simple apps, right? Put the logic where the action is. So why is it considered problematic for DDD?
Well, the smart UI means you pack a lot of business logic directly into the user interface.
Okay.
For simple applications, it's fast to build, sure,
Yeah.
and maintaining small, localized functions can seem easy, but its disadvantages are profound for complex systems. Integration between applications becomes incredibly difficult, there's little to no reuse of your core business behavior, and refactoring options are severely limited. You paint yourself into a corner.
Ah, I see.
Evans is quite emphatic. If you have a complex application and are committing to model-driven design, bite the bullet. Get the separation.
So resist the temptation.
The insight here is that smart UIs are a seductive trap. They offer short-term convenience at the cost of long-term maintainability, adaptability, and the true clarity of your domain model. They essentially bury the heart of your software.
Okay, so we've covered the high-level philosophy and how to structure your overall application with layers. Now let's get into the actual nuts and bolts of how you co-evolve an effective domain model and an expressive implementation. Evans introduces several tactical design patterns, or building blocks,
Right, the tactical patterns.
that refine basic object-oriented ideas specifically for DDD.
Let's look at some of the most fundamental ones. First, we have entities versus value objects. This is a really key distinction.
Okay, entities versus value objects.
Entities are defined primarily by their identity, not necessarily their attributes, and they have a thread of continuity through a life cycle.
Like a person.
Exactly. Think of a specific customer or a cargo shipment. They maintain their identity even as their attributes change over time. Even something like a handling event can be an entity identified by a combination of attributes that uniquely defines it in context. It has history.
And value objects are different because they're defined purely by their attributes and are interchangeable, like an address with a street, city, and postal code, or maybe a pigment color.
Perfect examples. They're conceptually whole and ideally immutable.
So if I have two address objects with the same street, city, and postal code, they're considered the same. You can just swap them.
Exactly. They are interchangeable. And that immutability of value objects provides significant advantages. Design freedom, inherent safety, because their state cannot change once created.
Fewer side effects.
And even opportunities for performance tuning, like sharing instances. Evans uses the analogy of electrical outlets. in a house design.
Right, if they're all identical.
If all outlets are truly interchangeable, you could conceptually share just one instance pointed to 100 times, which can optimize for very large systems.
Interesting.
The real power here is that value objects simplify reasoning about your code, reduce the surface area for bugs, and provide a strong foundation for building robust, predictable systems.
Then there are services. These are operations offered as an interface that stands alone in the model without encapsulating state. So they're typically named for an activity rather than an entity, a verb rather than a noun, like transfer money.
Right. They're crucial for functionality that doesn't naturally fit the responsibility of an entity or a value object. For instance, a routing service might calculate an itinerary, but the act of calculating doesn't really belong to a specific cargo or location entity.
It coordinates things.
Exactly. Services handle the doing when no single object owns that particular piece of behavior.
Next, aggregates. These sound incredibly important for maintaining consistency within our complex domain models. How do they work?
Aggregates are a cluster of associated objects that we treat as a unit for the purpose of data changes.
A unit, okay.
Each has a single root entity and a clearly defined boundary that enforces invariants, which are essentially business rules that must always be true for the aggregate as a whole.
Ah, the invariants, like business rules.
Yes. So if two users simultaneously tried to change different line items on the same purchase order, an aggregate would prevent a business rule, like PO violates approval limit, from being broken without nobody even knowing about it.
Because you lock the whole thing.
You operate on the whole aggregate unit. Locking the entire purchase order as an aggregate prevents this inconsistent state. It guarantees the consistency of the entire unit of data changes.
Got it.
The cargo aggregate example shows how delivery history and delivery specification can logically fit inside cargo's boundary, simplifying the model by ensuring related objects are always consistent together.
So it groups related things that must change together.
The key insight is that aggregates provide a robust mechanism to protect your core business rules from being violated by concurrent operations or partial updates, ensuring data integrity at the business level.
We also have factories, which encapsulate the knowledge needed to create a complex object or aggregate. They provide an abstract view for clients.
Yes. Factories handle the complex process of constructing or reconstituting complex objects or entire aggregates, ensuring their invariants are enforced from the moment they are created. They make sure objects start life in a valid state.
And they're different from repositories.
Yes, they are distinct. Repositories are concerned with finding existing objects. They provide the illusion of an in-memory collection of all objects of that type for aggregate roots, encapsulating storage and query technology away from the client code.
So factories make new things, repositories find old things.
Roughly.
That's a good way to think about it. And finally, modules. These are organizing principles for code and concepts. It's about low coupling between modules and high cohesion within them. But critically, they should reflect broad domain concepts like customers or shipping,
Right.
not technical partitions like entities or values.
That's right. Modules, when designed thoughtfully, allow your code structure to contribute directly to the ubiquitous language and aid understanding of the domain itself. They help manage complexity by grouping related concepts and code.
So the code structure should mirror the business structure.
Ideally, yes. It makes it intuitively understandable for anyone familiar with the domain.
Okay, we've built our tactical foundations. Now, Evans takes us into a much deeper realm, refactoring toward deeper insight. This isn't just about cleaning up messy code, is it? It sounds bigger.
Oh, much bigger. Not at all just tidying up. It transcends continuous code improvements. This is about a profound refactoring to a deeper model based on entirely new domain insights.
A breakthrough.
This kind of work can lead to what Evans calls a breakthrough moment, a complete paradigm shift in understanding.
You mentioned the Intel Loan Factory project. That sounds like a big breakthrough story. What happened there?
Right. The team was initially feeling pretty good after wrestling a challenging code base into a coherent model-driven design. They'd made progress.
Okay.
But then subtle rounding inconsistencies and increasing complexity in certain areas pointed to a more fundamental design problem. Something wasn't quite right at the core.
Little things adding up.
The breakthrough came when they realized our model tied together the facility and loan shares in a way that was not appropriate to the business. They had fundamentally misunderstood how these concepts interacted in the real world.
A conceptual flaw.
Exactly. And this led to the share pie insight, which removed an inappropriate constraint in their model. Suddenly, calculations were vastly simplified, and a large amount of special case logic was eliminated.
Wow, sounds like a huge success. Less code, clearer model.
It was a massive success in terms of simplifying the model and making it much more expressive and correct. Yet Evans describes the team's feeling as sick.
Why sick? After such a brilliant breakthrough. That seems counterintuitive.
Because despite the profound success, they were under a severe deadline, and refactoring such a significant amount of existing code without robust automated tests was incredibly risky.
The practical reality. High stakes.
Very high stakes, a sobering decision, yet it paid off. This breakthrough actually led to a cascade of new insights, revealing further missing concepts like transaction in banking, which had previously been only implicit in their system.
So one breakthrough led to others.
The lesson here is that true domain mastery often requires a willingness to fundamentally rethink and refactor, even when it feels daunting. Sometimes you have to take that leap.
Making implicit concepts explicit sounds like the absolute key to these breakthroughs. But how do you go about digging out those hidden ideas that aren't obvious at first glance? That seems like the hard part.
It is hard. One great example is the account accrual scenario. By noticing awkward responsibilities in the code and inconsistent business rules.
Smelling the problems.
A developer realized that the underlying concept of accrual was always present, but only implicitly. By making accrual explicit in the model and then the ubiquitous language, the design became far clearer, and the business knowledge moved from a series of ad hoc scripts into a well-defined domain layer.
So naming the concept made it real.
Precisely.
Yeah.
Sometimes the spark for this kind of insight can even come from simply reading a foundational book on the domain, like accrual basis accounting, stepping back and learning.
So the critical takeaway is that confusion, inconsistency, or awkward code are often flashing neon signs pointing to a missing concept in your domain model. Don't ignore the friction.
Exactly. Pay attention to those signals.
And once you've identified these new concepts, how do you make the actual code reflect them in a way that's easy for other developers to work with, to extend, and to change? That's where supple design comes in, right? It's about writing software for software developers.
Precisely. Making the code itself a pleasure to work with, or at least manageable. A core principle of supple design is intention-revealing interfaces.
Revealing intent. Makes sense.
This means naming classes, methods, and operations to clearly describe their effect and purpose without reference to the means of how they achieve it. What it does, not how it does it.
The paint mixing example from the book illustrates this perfectly. Instead of a vague paint method,
Which can mean anything.
transforming it into mix and paint and then extracting pigment color mixed with makes the design much clearer, safer, and easier to test because it reveals the true intent of the operation. You're not just painting, you're mixing.
Exactly. Much more precise. Another critical aspect of supple design is side effect-free functions.
Functional programming ideas creeping in.
To some extent, yes. The goal is to place as much of the logic into functions, operations that return results with no observable side effects.
Predictable outputs.
This makes code much safer to use, far easier to test, and allows for much safer combination of operations. It makes your code more predictable and less prone to unexpected behavior.
And related to that are assertions, which explicitly state postconditions, the guaranteed outcomes of operations, and class invariants about an object's state, like contracts.
Sort of, yeah. They help make any necessary side effects clear and aid understanding of how objects should behave. They document assumptions.
Okay.
Then there's closure of operations. This concept borrowed from mathematics.
Okay, getting a bit theoretical.
A little, but it's powerful. It means that an operation is closed under a set if combining any two elements of that set results in another element of the same set. Think of adding two whole numbers. The result is always a whole number.
Right, stays within the set.
Or the XSLT example from the book. It transforms XML into XML. The benefit is that it tremendously simplifies the interpretation and combination of operations, making your system more composable and consistent.
So you know what kind of thing you'll get back.
Exactly. When operations are closed, you can combine them confidently, knowing the result will always be within the expected domain.
Evans also talks about applying analysis patterns. What are these, and how do they give you a leg up in designing your domain? Are they like design patterns?
They're related but higher level. Analysis patterns are specialized patterns documented from experience, like those in Martin Fowler's analysis patterns. They provide pre-existing, well-thought-out models for common domain problems, such as posting rules for accounting systems.
So reusable domain solutions.
Essentially, yes. They give you a head start, saving you from costly trial and error by providing a proven starting point for complex conceptual problems.
And how do classic Gang of Four design patterns fit into the domain model? Can you just sprinkle them everywhere?
Not everywhere, no, but many can be directly applied to the domain by thinking about them conceptually, not just technically.
Okay, give me an example.
For instance, the strategy pattern isn't just a technical way to swap algorithms. It can explicitly model alternative processes that are meaningful in the problem domain, like a leg magnitude policy for a routing service deciding between the fastest or cheapest route. The strategy itself is a domain concept.
I see. And composite.
Similarly, the composite pattern can elegantly model part-whole hierarchies, where parts are the same kind of thing as the whole, only smaller, such as modeling nested routes within a larger shipment, again reflecting a domain structure.
But not flyweight. The book explicitly says, why not flyweight? What's the deal there?
That's a crucial distinction Evans makes. Flyweight is only an implementation option available for value objects. It's a purely technical optimization.
Like the electrical outlets example.
Exactly, like the electrical outlets example for saving memory. It has no correspondence to the domain model. It doesn't represent a domain concept. It's a technical decision to conserve resources, unlike composite or strategy, which model actual domain relationships or behaviors.
So distinguish between domain modeling patterns and pure implementation optimizations.
Absolutely vital.
So this entire evolution, from initial discovery to making implicit concepts explicit and designing for suppleness, it's an iterative discovery process. It's not linear.
Not at all. It's about actively searching for these concepts, involving lots of learning about the domain, lots of talking, and lots of trial and error.
You don't just get it right up front.
Rarely. It truly is a continuous cycle. You implement, you gain new insight, you refactor the model based on that insight, and then you refine the code to express the deeper understanding. This ongoing process is where genuine domain mastery and truly effective software are forged.
As projects get bigger, the challenge scales up dramatically.
Yeah.
Evans introduces strategic design for managing large systems, acknowledging that multiple models coexist on big projects.
Yeah.
How do you manage that reality without devolving into chaos? Because that sounds like a recipe for disaster.
It can be. The primary tool for managing this complexity is bounded contexts.
Okay, bounded context.
These are explicit boundaries where each model applies. This helps maintain integrity and avoids the inevitable contradictions that arise when a single term, like charge, means one thing in a billing context and something completely different in a vendor payment context.
Different meanings in different places.
Exactly. Bounded contexts are how you prevent your domain models from becoming a contradictory, unmanageable mess. You draw lines around where a specific model and its language are valid.
And to visualize this, you create a context map, which is a visual representation of these bounded contexts and their relationships, like a map of your software landscape.
Yes, and then you need strategies for how these contexts interact, or sometimes how they don't interact. One of the most important, and often a lifesaver, is the anti-corruption layer, or ACL.
ACL, okay.
This is where strategic design gets truly ingenious.
It sounds like a defensive measure, protecting one system from another, like a firewall.
It is exactly that, conceptually. An ACL is an isolating layer that translates between a new systems model and an external or legacy systems model, specifically to prevent corruption of the new system's own model.
Don't let the old messy stuff pollute the new clean stuff.
Precisely. Think of it like the Great Wall analogy Evans mentions. It acts as a barrier that allows regulated commerce-controlled data flow to pass through, but crucially impedes unwanted influence from foreign or legacy models.
So it translates and protects.
An anti-corruption layer is your shield, ensuring that external systems don't pollute the purity and clarity of your carefully crafted domain model.
Like the allocation checker example from the sales management system integration. It acts as an ACL to translate external category keywords into the new system's enterprise segments,
Right.
enriching the domain without adopting the foreign legacy model wholesale.
Exactly. It mediates. Other integration strategies exist too, each suited to different scenarios. A shared kernel, for example,
Shared kernel.
is when teams share a subset of the domain model and code, when functional integration is very high, but continuous integration for everything is just too much overhead. It's a tightly controlled shared space.
A compromise.
Or customer-supplier development teams, which formalize the relationship between upstream and downstream teams. The downstream team acts as a customer, defining needs, backed by automated acceptance tests to ensure their needs are actually met by the upstream team. It adds accountability.
So the customer's needs are paramount in that relationship. But what if integration isn't actually necessary or beneficial? Do you always have to connect things?
No, absolutely not. Then you can choose to go separate ways. Sometimes integration is simply not essential, and it's best for systems to remain independent, avoiding unnecessary cost and complexity.
Don't integrate just because you can.
Exactly. Evans recounts a project where some features simply needed access to existing data, not a full integration with a new proposed system. It's about recognizing when to connect and when to preserve autonomy. Be strategic about it.
And for multi-party integration, Evans mentions a published language. What's that?
Yes, this involves using a standardized protocol for multi-party integration, often an existing external standard, as the interchange model to reduce coupling and ease understanding. Think industry standards.
Like XML schemas or something.
Could be. The chemical markup language, CML, example, and XML dialect for chemistry allowed seamless data exchange and tool development like the Jumbio browser that wouldn't have been feasible otherwise.
So adopting a common standard helps everyone.
The powerful idea here is that a widely adopted published language can accelerate innovation and collaboration across diverse systems.
With all these models and contexts, how do you keep things focused? Because it's easy to get lost in the sheer scale of a large system. That's where distillation comes in, right? It's about focusing on the core of your domain.
Precisely. You have to find the signal in the noise. The core domain is the most valuable, distinctive part of your model. The real reason the software is being built, what gives your business its unique edge.
The secret sauce.
Kind of, yeah. This can be summarized in a domain vision statement, a short description, about 1 page, of the core domain and the value it will bring. It becomes a guiding star for resource allocation and modeling choices.
Where to put your best people.
Ensuring you invest your best efforts where it matters most.
And then there are generic subdomains. How do these fit in? Are they the opposite of the core domain?
In a way, yes. These are parts of the domain model that are general and reusable across many businesses, such as corporate organization charts, common accounting functions, or even time zones. They're necessary, but they don't provide your unique business value.
Stuff everyone needs but isn't special.
Right. Evans tells a fascinating tale of 2 time zones that really highlights this.
Okay.
In one project, a temporary expert adapted an existing public domain solution from BSD Unix and cleanly segregated it from the core domain. Quick, clean, effective.
Smart move.
In the other, a junior developer tried to build a time zone model a priori without specific application needs, which ended up neglecting the true core domain because it sucked up resources. Ouch. A common trap.
It's a classic cautionary tale. It highlights the risk of wasting your best developers and valuable time on generic problems that could be solved by leveraging existing solutions, buying off the shelf, or by a temporary assignment.
Right.
Allowing your core team to laser focus on the unique, distinctive parts of your business. The insight is clear. Don't reinvent the wheel, especially if that wheel isn't what makes your car special. Focus your energy.
Beyond subdomains, Evans also discusses cohesive mechanisms. What are those? They sound technical?
They are somewhat technical but in service of the domain. These are lightweight frameworks that partition complex computational logic into separate units with intention-revealing interfaces. They solve some sticky computational problem posed by the expressive models rather than representing domain knowledge directly.
Like helper frameworks?
Sort of. Think of a sophisticated graph traversal framework for an organization chart model, or maybe a framework for defining and combining specifications. They provide the computational muscle for your domain model without becoming part of it conceptually. They support the domain. Okay, let's talk about large-scale structure or evolving order. What are some of the ways to structure a large domain model to keep it manageable and coherent over time, beyond just bounded contexts?
One powerful way is through responsibility layers, which define conceptual layers around broad abstract responsibilities within a domain.
More layers.
Conceptual layers this time within the domain itself. Examples include operations and capability in shipping, or later, decision support. These layers define clear conceptual dependencies. Higher layers depend on lower layers conceptually.
Okay.
The hazardous material route policy service refactoring example shows how to maintain consistency within layers by shifting responsibility to its appropriate conceptual layer. You move logic to the right layer.
So an operational object shouldn't depend on a decision support object, maybe, and you refactor to maintain that consistency. It sounds like a way to prevent conceptual spaghetti.
Exactly. It enforces a conceptual flow. Another structure is the knowledge level, which is a group of objects that describes how another group of objects should behave.
Meta-level stuff.
Kind of. This allows for highly configurable behavior, like an employee type defining rules for employees and their retirement plans or payroll. It disentangles complexity when roles or relationships vary widely, preventing an explosion of conditional logic. You model the rules separately from the things they apply to.
Clever. And the system metaphor.
That's a concrete analogy to the system that guides thinking and is absorbed into the ubiquitous language. It can be useful for shared understanding, but Evans cautions against overextension or inaptness. Don't stretch it too far.
Okay.
Finally, for highly mature domains where diverse applications need to interoperate seamlessly, there is the pluggable component framework, which defines abstract core interfaces and protocols for interaction, like the Semitech IN framework for chip manufacturing, really for large-scale industrial integration.
That's a lot of strategic patterns and ways to organize. So how do you actually craft a plan with all these strategic design principles? Where do you even begin with such a monumental task? It seems overwhelming.
It can be. You must start with an assessment first. This means taking stock of your current situation, drawing a context map of existing systems and models, rigorously assessing the project's ubiquitous language. Is it rich enough? Is it consistent? Is it truly ubiquitous? And, most importantly, identifying the core domain with a succinct domain vision statement.
Know where you are before you decide where to go.
Exactly. Without this assessment, any strategic plan is just guesswork.
And who sets this strategy? Traditionally, it's the ivory tower architect.
Yeah.
But Evans clearly warns against that approach. Why is that problematic in DDD?
He does. Strategic design must apply across the project and requires broad buy-in and deep understanding. The decision process must absorb feedback directly from the application development teams,
From the people doing the work.
as they possess the deep understanding of the needs of the project and the concepts of the domain. There's a clear caution against siphoning off the best and brightest into separate architecture teams, as this often leads to overbuilt architecture that actually interferes with expressive implementations and leaves the core work struggling.
So the architects get disconnected.
The profound insight here is that strategic design isn't a top-down mandate. It's a collaborative, evolving effort driven by continuous feedback from those closest to the problem.
And famously, Evans says, beware the master plan, echoing Christopher Alexander's critique of master plans in city planning.
Right.
Master plans, he says, create totalitarian order, not organic order. They are too rigid.
Exactly. The most effective domain models are not rigidly defined up front and then set in stone. Instead, they're like, well, Evans uses the analogy of a new leather jacket.
Leather jacket.
Yeah. Stiff and unwieldy at first, but with wear, it becomes supple, molding to your body. Similarly, models that are transformed repeatedly with sound transformations, based on new insights and understanding embed ever-increasing knowledge, and reveal the broader conceptual contours of the underlying domain.
So the model gets better, more comfortable with use and refinement.
Your software should be like that leather jacket. Supple, adaptable, and constantly improving with real-world use and deeper understanding. It should evolve organically.
Wow. We've covered a huge amount of ground today, from the core problem of domain complexity to the intricate tactical patterns and the sweeping strategic approaches to managing it all.
It's a rich topic.
At its heart, domain-driven design is about prioritizing a deep, evolving understanding of the business domain.
That's the key.
And then meticulously reflecting that understanding in the software itself. It's an ongoing journey of continuous refinement, not a one-shot deal.
It's a powerful approach that yields lasting benefits. Evans shares a story about software for an olive grove project that was handed off with a supple design and a distillation document.
Okay.
The new team members, rather than being overwhelmed, became excited by the possibilities of the design, and the ubiquitous language sparked across to the other team and stayed alive, continuing to evolve.
So the understanding transferred.
That's the true lasting impact of DDD. It creates software that can grow and thrive because its core is built on a living, shared understanding. It has longevity.
What a fantastic vision to leave us with. So as you reflect on this deep dive, here's a final provocative thought for you, our listener. If knowledge is most valuable when understood and applied, what implicit concepts might be lurking in your daily work, waiting to be made explicit and transform your understanding?
Listen carefully to the language you and your team use. Observe where confusion or awkwardness arises in your current systems. Those are the clues. And don't be afraid to ask why something is the way it is. Often, the answer reveals a hidden insight, a concept waiting to be named.
Take this challenge. Explore your own domains with a fresh, DDD-inspired perspective, looking for opportunities to make your own work more supple and insightful. Thank you for joining us on this deep dive.
Thanks for listening.
We'll see you next time.